So, how a crystal structure is formed? So, in order to form a crystal structure, these two things has to be achieved: lattice plus basis. Okay, so lattice plus basis is equal to crystal structure. So you know that whenever we get any solid, okay, so in any solid, uh, the uh, the lattice points, the atoms or molecules are arranged in a systematic manner. So and they form a structure. It may be of various shape. So that can be achieved when these two things are satisfied. That is, lattice plus basis is equal to crystal structure. Now you already know what is lattice. Now what is basis? So basis is nothing but, in other way you can say, pattern. Okay, some pattern has to be followed. So this is how a crystal structure is formed. I wrote what crystal structure is formed by associating with every lattice point a unit assembly of atoms or molecules, identical in composition, arrangement and orientation. Now this thing is quite similar to what I have told you in our previous slide, that is crystal translation vectors. Okay, so in crystal translation vectors, what you have seen, that when you have a set of lattice point, then when some pattern is followed, when some uh, basis is followed, like at first I've shown you with only a vector a, then in the second diagram it was vector ab, and in the third diagram it was vector abc. So when we try to repeat the vectors in this whole space, then the entire lattice points can be generated. So once all these lattice points are covered in that space, then we get a structure or we get a crystal. So in short, you can say basis is nothing but a pattern which is followed in the lattice space. So that is what I want to say, because since we are doing uh, online classes and the resources are limited, because the board is also too small and they have various other limitations, internet problems. So I just want to focus on the main points, so that whenever whatever the notes that has been provided to you, when you read them, at least you understand something. So that is all about the basis and the crystal structure. So next is what I would like to tell you is about unit cell. So you see, uh, in your syllabus all these things are not mentioned. So in order to come to the particular topic that has been given, we have to cover all this. But still you can say that we are skipping many other things, because it is itself a crystal, the lattice points. This itself is a very big topic, very vast chapter. But we don't have any option. We have to skip those. So I directly came into unit cell. So what does unit cell means? It is again something similar to what we have learned earlier. When you have a set of lattice points, okay, when you have a set of lattice points, I have a lattice point like this. Okay, so now if I have a vector a, if I have a vector b, if I have a vector c, and then here d, then you see I'm getting a square shaped structure. So this square shaped structure is nothing but a unit cell. So as you go on repeating with the same thing again and again, a b c d, a b c, sorry, a b is there, now c d. So you go on repeating like this. If you go on, then all these points can be covered. You can just try it by yourself also. You go on repeating a, now c you have, now b, and then d. So you see, you go on with a b c d, a b c d, all these lattice points can be generated. All these lattice points in the space which is drawn can be covered. So this simplest cell ABCD is nothing but the unit cell. Okay, this is the unit cell. Now we are going to see next that what we are going to do with this unit cell.